Okay, in this video I'm going to explain how you use truth tables to determine the validity of an argument. Now an argument is going to be any, it's going to have to have premises, it's going to have a conclusion. In this problem you have actually J horseshoe tilde K, therefore J. Now you got to start by building your truth table. And to do that, we actually line these things up so that you have J horseshoe tilde K. You put a slash to separate the premises, tilde K, double slash is going to indicate the conclusion, J. Now, how many different letters do we have? So we just go through the normal build a truth table procedure here. You have two different letters. You have J and you have K. So two letters, 2 to the 2 is 4, so you have 4 lines. 1, 2, 3, 4. Now, underneath the letters, starting with the J, you have half true, half false. Now find every J. Half true, half false. Underneath the second letter, in this case the K, you have 1/4 true, so 1 true, then 1 false, true, false, all the way down. True, false, true, false. Then you work out your truth tables as we've been working them out up till now. You start, it doesn't really matter where you start. You can start with the first premise, the second premise, the third premise, fourth premise, whatever, then the conclusion. Doesn't matter which one you start with. But what you want to do is go right down your columns like we've been doing. So tilde T is F, tilde F is T, tilde T is F, tilde F is T. Now, I'm just going to stay within this premise. T horseshoe F is F, T horseshoe T is T, F horseshoe anything is T, F horseshoe anything is T. I hope you've noticed that with the horseshoe. Whenever the antecedent is false, the horseshoe is true. Now put a box around this because we finished off the truth values underneath the main operator of the first premise. Now go to the second premise. Tilde T is F, tilde F is T. Tilde T is F, and tilde F is T. So there's the truth values underneath the main operator of the second premise. Now the conclusion doesn't have any operators. If it did, we would work them out, but it doesn't here, so we just put a box around the truth values underneath the letter, that is the conclusion. Now, the next thing you want to do is you want to ask, is this a valid or an invalid argument? To do so, we look to see if there is a line that has all true premises and a false conclusion. If it does, then it is invalid. If there is no line where you have all true premises and a false conclusion, then it is valid. Now think about this. This goes back to your definition of validity. It's really handy to know this definition again. A valid argument is one where it is impossible that the premises are true and the conclusion false at the same time. Or going back to the definition as it is in the book, it is impossible for the premise or for the conclusion to be false given that the premises are true. So let's go down through this. Is there any line where all the premises are true and the conclusion is false? Well, let's look at the first line. False premise. No, you don't have all true premises, you have a false premise. The next line, true premise, true conclusion. Didn't break the rule. Next line, true premise, false premise. No problems there. The last line, true premise, false conclusion. There we go. There's our problem. If you have all true premises and a false conclusion, then it's invalid. Now, if we had worked this out and you didn't get a line like this, it would have been valid. Okay, so imagine a little different problem here. Let me write that one on the board. Okay, suppose you have an argument that works out like this. Suppose you have A horseshoe B in parentheses dot K. And then you have A or K. Therefore, you end up with B or K. Okay? Now, is this a valid argument? Or is it an invalid argument? Well, let's work it out. Let's say you have, let me see here, I gotta write this down. It's going to take a little bit of space. Let's just do it right here. You start off with your A horseshoe B in parentheses dot K. Now, there's your first premise. Slash, your next premise is A wedge K, and then your conclusion, B wedge K. Now, how many different letters do we have? Well, we have 3 letters, A, B, and K. 2 to the 3 is 8, so we have 8 lines. 1, 2, 3, 4, 5, 6, 7, 8. Underneath the A, you have half truths, 1, 2, 3, 4, and then half falses. Find every K, find every A. 1, 2, 3, 4. 1, 2, 3, 4. Now, the second letter is B. We're going to go 2 truths, 2 falses. 2 truths, 2 falses. And then every other B right over here, true, true, false, false, true, true, false, false. Then under the K, alternating, true, false, true, false, true, false, true, false. True, false, true, false, true, false, true, false. True, false, true, false, true, false, true, false. Now you just end up working this out, just like we've been doing. Okay, so what do we have? Let's start here. I'm going to start within the parentheses and work my way out. I've got T horseshoe T is T. T horseshoe T is T. T horseshoe F is F. T horseshoe F is F. Then F horseshoe anything is T. That makes that a little bit quicker. Now the dot. I've got T dot T is T. T dot F is F. F dot anything is F. F dot anything is F. T dot T, T. T dot F, F. T dot T, T. T dot F, F. So there's the set of truth values underneath the main operator of the first premise. Now let's go to the next premise. We got T wedge anything is T. 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 F wedge T is T. F wedge F is F. F wedge T is T. F wedge F is F. So there's the main operator underneath the second premise. Now, the conclusion. T wedge anything is T. T wedge anything is T. F wedge T is T. F wedge F is F. T wedge anything is T. T wedge anything is T. F wedge T is T. F wedge F is false. Now, are there any lines where both premises are true and the conclusion is false? Well, let's go down through here. You've got T, T, and T. That doesn't break the rule. F doesn't break the rule. F doesn't break the rule. F doesn't break the rule. T, T, and T doesn't break the rule. F doesn't break the rule. T, T, and T doesn't break the rule. F doesn't break the rule. So there's no line where you have all true premises and a false conclusion, so it is valid. Okay, so there were 2 examples. You can work out your own problems, but go to the book and practice these. But if you get practice, you'll find that it's fairly easy, but you need to know your definition of validity and you need to know your truth tables. Thank you very much.